Today I show you how to add an orbit to your simulation based on state vectors. We define state vectors as the position and velocity vectors for the spacecraft at a specific time. These can be those observed for an existing spacecraft or those proposed for a future spacecraft. These vectors must be referenced to a known inertial coordinate system. We use a geocentric, non-rotating system that we call the Earth-centered inertial, or ECI, coordinate system. Again, we start by clicking on the New button. This ensures that we are starting with no existing satellites in our simulation. Next, verify that the Start Time Always Now checkbox is not checked. Then, verify that the Satellite Ground Lines and Satellite Ground Steps checkboxes are checked. Finally, change the size of spheres to 18. Do this because, today, I'll show you how to use ground tracks to get more information about where the satellite will pass over the surface of Earth. Now, set the simulation start time to sometime in the future. Just don't make it more than 100 years. After clicking the mouse outside the date-time tool, set the simulation time span to 4 hours, making sure you place colons between hours, minutes, and seconds. Then, press the Tab key and recalculate the orbit. Click on the Add Satellite button to add a satellite or spacecraft. You should now see the Set Initial Parameters dialog. From this dialog, select the State Vectors option. Note that you can enter the position and velocity vectors, and you can change the epoch. Epoch is the date and time when the state vectors are valid. The default epoch value is the simulation start time, but you can change this to any time inside the time span for the simulation. The date and time you see may be different from what we show here. Now, add 2 hours to the existing epoch. This is 2 hours later than the simulation start time. Don't worry, the software will propagate the satellite backwards in time to the simulation start time. In the X-position text box, enter 7 million meters and then press the Tab key. In the Y-position text box, do the same. Again, do the same in the Z-position text box. Keep in mind that the average radius of Earth is 6,378 kilometers. Therefore, you cannot set the magnitude of this radius vector to less than this. In the X and Y velocity text boxes, enter 1,000 meters per second, pressing the Tab key after each one. In the Z velocity text box, enter -6,000 meters per second and then press the Tab key. Now click on the Set Parameters and Recalculate Orbit button. You should see an orbit similar to what we show on my right, except your Earth rotation may be different due to the different date and time. Use the mouse wheel to zoom out so you can see the entire orbit. Note that the spacecraft is not at the same position as the epoch. The spacecraft is located at the simulation start time, while epoch is where the larger pink sphere appears 2 hours later. Essentially, the software has propagated the spacecraft backward in time from epoch to the simulation start time. Note that the position spheres between the simulation start time and epoch are colored green rather than red. This indicated negative time propagation. Click on any of the position spheres, red or green, to see more information about the position vector, the spacecraft's speed, the date and time the spacecraft was at that location, and the look angles for the spacecraft relative to your location on Earth. Next, click on one of the white ground step spheres. It will give you information about when the satellite will be over this Earth location. It also gives you the GPS coordinates for this location. Now, increase the simulation time by 2 days. Press the Tab key and then recalculate the orbit. This will allow you to see more of the ground track. Since this is a polar orbit, all ground tracks intersect at the poles. If you want to save your orbit project, click on the Save As button and then choose a name for your project. Thank you for watching this video. We hope you enjoyed it. If you did, please give it a like and consider subscribing to the channel. We will be producing new content in the future, so it is also worth hitting the notification bell. We would love your feedback, so leave a comment in the comment section. Until the next time. Goodbye.